All right, example number one. The expression. We have to first isolate the expression and then isolate the symbol. So 4 radical x, that's the term with the radical symbol. So we need to isolate that term first. We'll isolate that term by adding 1 to both sides. Now we have 4 radical x equals 4. Now we need to isolate the radical symbol. Tessa, how are we going to isolate the radical symbol? Divide both sides by 4. Radical x equals 1. Now that we have the radical symbol isolated, we must get rid of the radical symbol by doing what? Brenner, squaring it. So we'll square both sides. So we'll square this, and then we'll square that. Squaring it is how we get rid of the radical symbol. The only thing left now is x. 1 squared is 1. So x equals 1. When solving radical equations, we have to check our answer. So if x equals 1, let's do a quick check, see if that works out. Let's see if x equals 1, if that checks out. So 4 times the square root of 1 minus 1, does that in fact equal 3? 4 times the square root of 1, the square root of 1 is 1. So 4 times 1 minus 1, does that in fact equal 3? And as you can see, 4 minus 1 does equal 3. Example number 1, does anyone have any questions? All right, let's take a look at the next one. And like always, if you think you've got the hang of it, you can get started on your classwork at any time. All right. So the first thing we need to do is isolate the term that contains the radical expression. So the square root of 2x minus 3, that's the term with the radical symbol. We need to isolate that term. We'll isolate the term by doing what? Brenna? Subtract 3 from both sides. Minus 3 from here. Minus 3 from there. We have radical 2x minus 3 equals 5. Now that the radical symbol is isolated, we need to get rid of the radical symbol. We'll do that by squaring both sides. The process of squaring gets rid of the radical symbol. We have 2x minus 3, no radical symbol, equals 5 squared, which is 25. Now that the radical symbol is gone, we could solve for x. Add 3 to both sides. Two x is equal to 28. Divide both sides by 2. X is equal to 14. Again, whenever we solve a radical equations, we have to check. Sometimes we could have extraneous solutions. Extraneous solutions are solutions that work out algebraically, but they don't work when we check it. So let's do a quick check. X is equal to 14, so 3 plus the square root of 2 times 14 minus 3, does that equal 8? 3 plus the square root of 28 minus 3. Does that equal 8? 28 minus 3 is 25. 3 plus the square root of 25. Does that equal 8? Square root of 25 is 5, so 3 plus 5. And as you can all see, it does indeed work out. Those were radical equations. Any questions on those two examples? Now let's see what it looks like when we have exponential form. So again, remember we have radical form and exponential form. So this is radical form. These are radical equations. Now let's solve an equation with a rational exponent. Rational exponent. Please copy this example into your notebooks. The process is exactly the same. We must isolate the factor or term that has the rational exponent. This is what I mean when I say rational exponent. We have to isolate this factor first. This factor must be isolated first before we could get rid of that exponent. Brianna? Divide by 3. Divide both sides by 3. X minus 2 raised to the 3/4 power equals 8. Now I need you all to put your thinking caps on. We need to get rid of that exponent. In other words, we need this exponent to be 1. Does that make sense? For example, say we have x to the first power. The exponent is 1. You never have to write the 1, so it's as if there's no exponent there. Does that make sense? So if we could find a way to get an exponent to be 1, that means there's no exponent there. Does that make sense? How can we turn this exponent 3/4 into 1? Because if it's 1, then we get rid of the parentheses. How can we turn 3/4 into 1? Just think about fractions. 3/4 times what equals 1? The reciprocal. So we'll multiply by the reciprocal. 3/4 times 4/3 is 12/12, which is 1. So the way we could get rid of rational exponents, or in other words, turn it into 1, is to multiply by the reciprocal. What's the exponent here? Right now? 1. So you have to keep in mind that you don't always see it, but there's an exponent there. It's 8 to the first power. If we multiply this side, the exponent on this side, by 4/3, whatever you do to one side, you must do to the other side. So we must multiply this exponent by 4/3. Does everyone follow what's going on here? 3 times 4 is 12/12. So this is essentially 12/12. And 12/12 is 1. So now this is to the first power. So essentially what happened here is we canceled all of this out. Now we just have x minus 2. Because x minus 2 to the first power is just x minus 2, no parentheses. Does that make sense? All right, you got to remember that. That's how we get rid of these these rational exponents. Now we have 8. 1 times 4/3 is 4/3. So this is 8 to the 4/3 power. What is 8 to the 4/3? You have calculators. You could do convert it to radical form. If you want to do it algebraically, it's up to you. What is 8 to the 4/3? 16? X minus 2. What's going on with the smart board? X minus 2 equals 16. Now we could solve for x by adding 2 to both sides. X equals 18. Let's just check our work real quickly. to make sure that that is indeed an acceptable solution. So when we check, we just substitute 18 for x. We have 3 times 18 minus 2 raised to the 3/4 power. Does that equal 24? I don't know. We'll see. 18 minus 2 is 16. 3 times 16 raised to the 3/4. Does that equal 24? What do I do next? Do I do 3 times 16 or do I do 16 to the 3/4? Order of operations, which one do I do first? 3 times 16 or 16 raised to the 3/4? Not you, Brianna. Madeline. 16 raised to the 3/4. Order of operations. So tell me what 16 raised to the 3/4 power is. Somebody throw that into your calculator, please. And tell me what 16. Francis, 8. So this is 3 times 8. And as you can see, 3 times 8 is, in fact, 24. So it checks out. The answer is 18. X equals 18.
When you do reciprocal, like when you use the reciprocal, are you using that all the time in this case?
Yeah, for rational exponents. So when you have an exponent that's a fraction, always use the reciprocal to turn it into 1. Always multiply by the reciprocal. So the product is 1. One more example. This last example has a small little caveat that you have to know. So please take this one down. And I'll tell you what the caveat is before we start solving here. This is the last one, and then you can break off into your groups. You'll have a full solid 20 minutes to do classwork. You should get most of it done in class. All right, the caveat is here. When you have a rational exponent, so in this first example, we had a rational exponent. The exponent was 3/4. And this exponent is 2/3. The numerator here, the numerator is odd. The numerator is even here. So copy this down, please. When the numerator is even for the rational exponent, when the numerator of the rational exponent is even, you must use absolute values. And I'll show you what this means in a second. When the numerator of the rational exponent is even, you must use absolute value. All right, so let's solve this, and I'll show you what this means. Did everyone get a chance to write that down? So again, we want to begin by isolating this expression. We want to isolate this factor with the rational exponent, so we'll divide both sides by 3. We have x plus 1 to the 2/3 power equals 4. Now we need to get rid. All right, so essentially this the numerator is even. So after we get rid of the exponent, we're going to replace the parentheses with absolute value. Since the numerator is even, once we get rid of this exponent, we're going to have absolute values, and we're going to solve an absolute value equation. But before we do that, how do we get rid of this exponent? What do we multiply it by to get a product of 1? Which is,
1.
that's not the reciprocal.
I mean, sorry, 3 over 2.
3 over 2. Again, this is 4 to the first power. So we multiply by 3 over 2. Multiply this 1 by 3 over 2. This cancels out. So we have x plus 1 inside of absolute values. The reason we use absolute values is because the numerator was even. 4 raised to the 3 over 2 is what? Did anyone get that? Jordan?
It's 8.
8. All right. So the absolute value of x plus 1 equals 8. We solved absolute value equations, I think, in unit 1 or 2. But the thing is, when you solve absolute value equations, you just do plus or minus. So x plus 1, since this is absolute value, x plus 1 equals 8. And another one, since it's absolute value, x plus 1 equals negative 8. So when you solve absolute value equations, it's going to be 2 separate equations you're solving. One of them is going to be positive, this expression. The other one is negative, the opposite expression. And then we'll have 2 solutions for x. So we'll solve both of them for x. Subtract 1, x equals 7. Subtract 1, x equals negative 9. So I repeat, when your numerator of the rational exponent is even, you know you're going to have 2 solutions. If the numerator is even, you have 2 solutions. We have 2 solutions because we use absolute value. And we'll check to make sure both of these are correct. All right.